An ideal gas is compressed to half its initial volume by means of several processes. Which of the process results in the maximum work done on the gas? Okay. Then if I draw the diagram of the PV curve, that means the pressure versus volume curve. This is the pressure versus volume curve. The y-axis indicates the pressure and the x-axis indicates the volume with the variation in the pressure. Then isothermal means PV to the power of C is equal to constant. The curve looks like this. This is the curve for isothermal. And adiabatic, that means the PV to the power of gamma is equal to C. This is the curve for the adiabatic process. And isobaric, there is a constant pressure. The curve looks like this. Then isochoric is the constant volume. It is the work done is equal to 0. We know that one, right? Then in this case, okay, this is the where PV to the power of gamma is equal to C. This is adiabatic process. And this curve is the isothermal process. And this is the isobaric process. We know that the work done on the gas is equivalent to the area under the curve, PV curve. If you observe this curve, this is the isobaric curve under this curve. The area is very less comparing to the isothermal. Then this is not will give the maximum work done. And comparing to the isothermal to adiabatic, in the isothermal work means area is under this one comparing to the adiabatic. So the area under the curve is maximum in adiabatic process. Then we'll get the maximum work done on the gas occurs during the adiabatic process. Then option B is the right answer.